Hey folks! Welcome back! In this video, we'll be building a countdown timer using Python. All you need is a basic working knowledge of Python. Even if you don't, this video should give you an idea of what Python is capable of. If you are an absolute beginner, please check out the playlist on programming with Python. But, in this video, we'll be seeing how easy it is to build a countdown timer. All you need is a Python interpreter. You could use Anaconda Navigator, PyCharm, or any local development environment of your preference. If you are testing the waters, Google Colab is a great option. Head over to your Google Drive and right-click. Click on More, and then select Google Colaboratory. That is all. This will create a notebook environment where you can code and see the output in a single place. Notebooks are the best for experimenting. You do not have to install anything on your machine. Google Colab comes as a plug-and-play option, and it is absolutely free. We now have the setup ready. Yes, it is that simple. Let's crack on. We shall familiarize ourselves with the concept before we dive into the coding part. First and foremost, we need a Python interpreter. We will be using Google Colab today. We need a stylish background for the timer. If you're into minimalist design, a simple solid color background could work. Regardless, create an image with the desired dimensions. Let's go with 1280 by 720 pixels for a nice resolution. Next, we'll generate a series of images by overlaying the time onto that background. For this, we are going to use Python Image Library, PIL. Finally, we'll compile these images into a video. For this, we'll use OpenCV. We'll add NumPy to the mix for optimization. Sound good? Awesome! Now, let's get to the fun part and start coding. Python is an amazing programming language that makes it easy to create exciting projects. With its extensive standard library, you can quickly import and use various modules for your tasks. For example, on your screen is all the code needed to create a 12-hour countdown timer. The first and most important step is the imports. In this case, we're using the Python Imaging Library, PIL, and OpenCV to build the timer. PIL, which is part of Python's standard library, handles image processing tasks. We import three classes from the PIL library. The image class is used to load the image. ImageDraw class is used to overlay the timer onto the image, and the ImageFont class is used to specify the font to be used. OpenCV is a robust tool for image and video processing. We'll be using this for compiling the images into a video format. If you're using Google Colab, everything you need is already pre-installed, so you won't have to worry about setting up the environment. We use two functions here to make the code maintainable. Functions are a good way to make the code reusable and modular. Any production standard code will make use of functions, or classes, for modularization. It is a very good practice. getTimeFormat is the function we use to format the seconds into hours, minutes, and seconds format. The output of this function would be a string in HHMMSS format. The createTextImage function takes in the duration as a number of seconds. It uses the getTimeFormat function to reformat the duration into HHMMSS format. Then, it overlays the timer onto the base image. We can specify the x and y coordinates of the position of the timer. We can also decide the font and the color of the text. We then convert the image into a NumPy array to make the processing faster. NumPy is a library that is indispensable in the world of data and is known for its optimized numerical computing capabilities. Now, choose the font and the base image on which we overlay the timer. For the purposes of this tutorial, we have chosen a 1280 by 720 pixel image and Bank Gothic Bold TrueType font. We'll use the image and image font classes from the PIL library to load the image and the font. To make the timer appealing, let us set the size to 180 pixels. We also initialize a video writer object from OpenCV, which is imported here as CV2. This video writer object takes in a series of images, or images represented as NumPy arrays as input, and compiles a video file. It takes in an encoding format and the frames per second. When we convert an image of 1280 by 720 pixels into an array, it takes a shape of 1280 by 720 by 3. The 3 indicates the number of channels, red, green, and blue, in that specific order. Each element of the array will have values ranging from 0 to 255, where 0 is pure black, and 255 is pure white. The color of every pixel is a combination of the values in these 3 channels. You'll probably know by now that a video is just a series of images played in quick succession. Videos have something called frame rate, which is the number of frames per second. Typically, videos have a frame rate ranging from 20 to 30, sometimes 60. The more the frame rate, the smoother the video. But, as we are dealing with seconds, it should be enough if we write 1 frame per second. Let us choose MP4 as the format of the countdown timer video. So, the encoding, or video writer 4cc parameter, is supplied with 4 characters, M, P, 4 and V. The asterisk before the string MP4V does the job of expanding a string of 4 characters into 4 individual strings. Now that we have understood the component parts, let's look at how we'll execute those. We use the range object, which is a generator data type in Python. It does not hold anything in memory, and generates the numbers on the fly. We calculate the number of seconds in 12 hours, and iterate down to 0. Since the upper bound is not included in Python, we'll have to set the second parameter of range, stop, to -1, so that the timer ends on 0. The third parameter to range object is the step size. It decreases the loop variable by 1 in every iteration, essentially counting down to 0. In every iteration of the loop, we convert the seconds into HHMMSS format. We make a copy of the template image and overlay the timer on it. Then we convert it into a NumPy array, setting the data type to int8, since the values range from 0 to 255. This saves some computational resources and optimizes the process. We feed the array to the video writer object, which holds them in buffer memory. There's one small thing we need to take care of. OpenCV uses a BGR color scale rather than the traditional RGB color scale. So, we'll have to make a minor adjustment to retain the colors. That is what's going on in line number 26. When the loop is complete, and all the images have been generated, we call the release method on the video writer object, which writes the video file in MP4 format to the mentioned path. This is the end product of the code. This is a sped-up sample, but you get the point. That is all for the demo of creating a timer video in Python. Did you know that it took only 8 minutes to create a video that is 12 hours long? Check out the full timer video. The link is in the comments. More importantly, try running this for yourself. So, in essence, we took a template image, made 43,200 copies of it, each time writing a countdown timer on top of it, and compiled a 12-hour-long video. All in under 8 minutes. For more interesting tutorials, like, share, and subscribe. Don't forget to hit that bell icon. Until next time, happy learning!